In this example, we're going to find the local maximum for the function defined as the integral from 0 to t of x squared plus 12x plus 32 all over 1 minus cosine squared dx. So this is a little bit unusual from what we've seen so far in the class as far as a function that's been defined this way. We haven't seen this yet. But just like any other function, we still have to follow the same rules when we find a local max or a local min. And what we normally do for any function is we take the derivative, we set it equal to 0, find the critical values, and then determine which ones are maxes or mins or neither. So that's exactly what we're going to do here. So we need to take the derivative. Let's do this. We're going to take the derivative of both sides. So now we have it set up actually perfectly for using the fundamental theorem of calculus. This is set up where we have a 0 down here. And what we do is, for the fundamental theorem of calculus, when it's set up this way, this tells us that the derivative is going to be whatever this is, evaluated at t. So when I take the derivative of f of t, that gives me this. Then, using the fundamental theorem of calculus, we'll get t squared plus 12t plus 32 all over 1 minus cosine squared t. Now, I have to set this equal to 0 to find the critical values. Now, as long as the bottom isn't equal to 0 at the same time as the top, we can just look to see what makes the top 0. Because when the top of a fraction is 0, it doesn't matter what's on the bottom other than if it's 0. It doesn't matter what's on the bottom because 0 over 5 or 0 over 7 is going to be 0. So we're going to focus on the top, and then we're just going to make sure that we don't get something that creates a 0 on the denominator. So this function is very easily factorable. If you don't want to factor, you can use the quadratic formula or complete the square method. But this one factors nicely. So I'm looking for what would multiply to give me 32, but add to give me 12, which would be 4 and 8. So my two possible answers are t is equal to -4 or t is equal to -8. So now we need to put these on a chart and check to see where the function is increasing or decreasing, or I should say the derivative. And then that way we can determine where this local max or local min occurs, or it could be neither. But looking at this, since t is -4 and -8, if I plug that into the t in the denominator, that does not make that 0, so we're good there. So we're going to create a chart and do test values. So we have -8, -4. And so what we're going to do, I'll pick, say, -10 as a test point. Between -8 and -4, I'll pick, I don't know, let's say -7. And then for greater than -4, I'll choose 0. So what we're going to do is we're going to plug these values in to the derivative to see where it's negative, where it's positive, and then we'll have a better idea of what -4 and -8 are as far as mins and maxes. So when I plug in -10 into the derivative, I'm going to get a positive number. So this interval here is positive, which means it's increasing. When I plug in -7 into the derivative, I'm going to get a value that is negative, which means on this interval it's decreasing. And then when I plug in 0, I'm going to get a positive number, which means it's increasing. Now, when I look at this, I picture, because it's increasing and then it's decreasing here, and then it's increasing here, that means this is going to be a minimum because it's decreasing on one side and increasing on the other. And for -8, since it's increasing on one side and decreasing on the other, this is going to be a max. So for the final answer, I would say that t is equal to -8 is a local max.